Hey, tonight we are going to be working on this 2012 BMW 650. It's got the 4.4 twin turbo V8. Customer towed it in and told me it was making a loud noise when it's running, so he told me to check it out and see what it's going to be. Let me get you a clip of what it sounds like. And sometimes it comes and goes, but it's pretty consistent. Alright, so that's what it sounds like. Being the fact that we have an obvious mechanical engine noise, possibly just bad engine. I did add a curiosity because I saw an engine malfunction code or error message displayed. I went ahead and scanned the engine computer just to see what was in there. You can see obviously we have a misfire number 8, but the ones that I was interested, or not interested in seeing, but thought was cool to see, the knock sensor 2 and knock sensor 4, both displaying engine noise above limit value. So knowing now that we've got a car with possibly a rod knock, this is something that I wanted to do for a while now. I've tried it on a couple other cars, but I wasn't really successful on it because of the way the ignition system was set up. So again, we know we've got a known controlled condition. Basically, we know that the engine has basically a rod knock. At that point, what I want to do is see if we can use the scope to identify which cylinder has or is creating this noise, this rod knock. So I wanted to hook up again like I had in the past and take some measurements and try to isolate or narrow down based on the signals that I'm gonna take. What I'm using to do that is I'm gonna use the chassis ears to hook up to the engine block, one on each bank, to see if one side is louder than the other. So I'll use 2 microphones hooked to the scope. There is a previous presentation that I had done on how to use the how to set this up on the scope. So we're definitely gonna be able to pick up the rod knock. So we're gonna be using these. So 2 channels for that. A transducer with an oil pressure test kit, and I'm gonna take a reading of the oil pressure and see if there's any type of oddball changes. And then I'm gonna sync also ignition cylinder. I'm gonna pick number 1 and see if we can find which rod is knocking. Just a small tip, if for doing BMWs you have to have a special fitting adapter. None of these will work, or actually any of the other kits I've gotten don't have the correct fitting for the BMW in case. Now this is an old piece that I got years ago, so I don't know if that part number is good, but you're gonna need this piece to do BMW oil pressure testing. So I'll just couple that with that and transducer, 2 mics. We'll go from there with the ignition and try to see if we can isolate this. I want to get a shot of the setup I've got going on. I've got my oil pressure tapped in with the transducer. Then on each bank I've got the chassis ears clamped, and then from there I've got the ignition on number 1 tapped in. And I'm letting it run while monitoring all the channels I got set up. And we'll see what it looks like. See if we can see anything on the oil pressure waveform. I actually wanted to get a shot of this after scoping it and seeing what I saw. I was curious to see what was available in live data, since it was able to actually log some sort of trouble code for knock sensor related. And I did find these PIDs here that are basically individual cylinders knock sensor signal. Even though there's only 4 knock sensors, 2 per bank, I'm pretty sure, yeah. In some way, somehow is able to individualize down to one particular cylinder. And as you can see, this guy here, cylinder 4 is what's being described and labeled as, has the highest voltage range. Just thought I'd get a shot of that. It does have PID for individual cylinders, and it is actually isolating one in particular. Here I am running a test with the oil pressure with ignition sync. Set up same way, same cylinders on the scope, just to try to get one for comparison, see what a known good looks like. Obviously I'm not running the microphones for knock, since this vehicle does not have a knock. This is, you see ignition strike there and then a multi-strike there. This is at idle during warm-up. What I believe what we're seeing, after also looking at service information, they run a strategy during warm-up where they will do kind of like multi-strike. They'll do multi-strike at idle. BMW is known for doing that, but usually it's a one long section. This is like a one strike and a couple strikes, sometime afterwards. I believe what we're seeing here is the multi-strikes after the main one. I'm calling it the main one, is what they call spark plug cleaning. I actually wrote it down. They call it follow-up sparking. It's a strategy for cleaning the spark plugs. I believe that's what we're seeing there. So whether I'm 100% right, I don't know, but I'm kind of just generalizing things for the moment. So I'm picking this one for now to try to just identify some, putting some sort of sync in there to try to put in the firing order. Now the firing order is 1548637 You cut that in half. 4 companion cylinders, these are your guys. So 1548637 So this, we'll call this column, is for cylinder 1, 5, 4, 8, 6, 3, 7, 2. This drop here and this microphone noise is happening in what I'm going to call the cylinder 4 column. So 1, 5, 4. You're getting that like drop of pressure, what looks to be in the cylinder 4 area, firing area, and the microphone is picking up noise in that cylinder 4 area. Now if you remember what the scanner pulled up in their data, was cylinder 4 knock voltage was the highest one that it was displaying. So that was exciting, sorta. See, after seeing the scanner and then pulling this up and picking up the noise in what would be quote unquote the number 4 cylinder firing column, and then a drop of oil pressure in that same column was kind of exciting. So now I'm getting, like it was worthwhile doing this. So then I try to justify or see what's going on with this second portion. I'm calling the second portion of oil pressure loss. And that falls actually in so the last one's going to be 2, the one before that is going to be cylinder 7, is where you're having the other, loss of pressure according to this. And then number 7, if you see number 4 and 7 are companion cylinders. So loss of pressure from what looks to be number 4 is also occurring in the number 7 column, but companion cylinders, number 4 can be affecting number 7 column as far as oil pressure activity or reading or loss of it at that point. So now I'm pointing to number 4, first foremost scanner. Number 4, microphone noise. Number 4 column, loss of pressure. Companion cylinder for number 4, loss of pressure in the number 7 column. I hope you're following me. That's at idle. Let's go again to the same section. And let's see where the idle starts to go up. And I'll put up the rulers, but I'll tell you right now, it all lines up the same. The high microphone noise in that column for number 4, and then the with the oil pressure drop, and again it's repetitive in that area for number 7 column, which would be the companion. And then lastly, I'll show you in higher rev and holding the rev. I can't remember, maybe it was 1500 or so. I didn't want to go too high. Again, we're definitely pegging out higher on our over 100, so it's getting clipped off, but we're getting 2 drops in the same cycle still. Even though we're at higher revs, you're still seeing 2 drops. Here is your increase in microphone noise. Again, still same column. The third one over, cylinder 4 column. And now, let's see if you can pick that up. So the second one in from then, that is column 7. And now we're picking up noise there, and also what seems to be like the beginning of the effects of oil loss. So now we're getting noise column 4, column 7, oil drop. Again, just like at idle, just this more at a higher scale, sort of say. And again, with having that in our heads now, with what the scanner was saying about cylinder 4 having a knock, it just keeps pointing to number 4. I luckily had a second vehicle here that is a known good N63. It is in an X5. I just did a sync for same cylinder, number 1, and oil pressure. I didn't hook up the microphones or anything. So here's the oil pressure. And I kind of got down a little because you're seeing some repetitive unsteadiness also. And this is a known good engine. But we're at idle here. So here's your sync, and then here's a portion that's lower spikes, a second one, and then a portion with high spikes and a second one, all in that same cycle. So then, looking further into it, I checked here at the idle raise, and then again you're seeing the repetitive small, big, small, big, small, big. And what I noticed was once I started to rev, it seemed to get, I'm going to call it better as far as consistency. The pulsations all get closer in, peaks and valleys. Like it, I'm going to say, like it fixed itself. So the more the RPM, the more consistently the same they got. Obviously, they're not identical, but it's definitely not portions of low, high, low, high. It's more of a closer consistency. Lastly, we'll do where I did a hold and a hold the revs up, and there it looks a whole lot better when you're holding the revs and high RPM, and your oil pulsations seem to even out and seem to be almost the same. So this is a known good with some RPM and no big dropouts, almost a consistent type of looking graph or waveform, whatever you want to call it. So that, seeing this made me realize that we do have a true drop in oil pressure that is not in a known good. This portion here is when I revved it up and held it and we're maxed out, but even at this higher rev, we're getting maybe higher drops in pressure that are consistent. So even with higher revs, it did not quote unquote fix itself as far as pulsations. There were still big heavy drops of oil pressure. So what I'm getting at is, being that basically the bearing's probably completely gone, too wide of a clearance, you're going to lose oil pressure, and your pressure reading is dropping. So it's making sense. You're seeing the loss of oil pressure, and it dips down here at high RPM because the quote unquote the bearing is gone. And like I said, this is when you're trying to rev it up, the pulsations still don't even out. You're still having two dropouts. Get a light here. So there's the lower pan. Here is the oil pump, and here's what it looks like. So you clearly have zero access to all front cylinders except for the two in the back, cylinders 4 and 8. So off to this side here, passenger side, is this way is going to be 4, this way is going to be 8. So I came, and this guy here, the one more forward. Now, as soon as I got access to it like this, again, kind of got a little bit down, because just from my experience, when you have a rod knock, if it's bad enough, and they've gone long enough, you'll generate some heat, and you'll get the discoloration from the heat on the rods, and these are not discolored at all. So that was not what I was expecting. No movement, and now everything that I saw and information I gathered and everything I broke down just was like, didn't make sense. It made sense, but now it doesn't make sense. And just for out of curiosity, I looked down this way, and sure enough, that rod is got some discoloration from heat, and you can actually see part of that, the bearing shell there. So at that point, and I'll try to do this. Let's see. I hope you can hear that. That rod is the one making our noise. That is the rod knock. That guy right there. And as soon as I look up and where it points to, it points this way, towards the driver's side. The second one in from the back, that makes that cylinder number 7. So this whole time, cylinder 7 is the one that's causing all of the things that we are seeing. So everything we are looking at, have looked at, and seen is being caused by cylinder number 7 rod knock issue. All the companion cylinder stuff still comes into play, but instead of thinking that it's due to number 4, it is because of number 7. Obviously 7 is going to be in the same either position, being companion cylinders, which makes it look like also number 4 has a problem, but it's number 7 that affects this number 4 area, as well as itself number 7 area, due to at that point oil pressures being lost in the, I guess, top dead center positions is where you're mostly seeing the lost pressure. Here you're picking up knock in both columns, and it's always greater in this area, obviously, as we have seen. The only thing I can think of, and it's just what I can think of, I don't know why on other ends or not, it's not working or being noticed as much. At this point, top dead center number 4 is supposedly in the firing area, so number 7 would be top dead center exhaust. Okay. Now, this is just a generic rod. The only thing I can think of, say my fingers the crank pin, and obviously they're not touching, but because of the oil pressure film, say we're going on an upstroke towards TDC, the crank is what's going to drive it. So my finger's going to push this upward. The crank's going to push the rod up. And on the power, or on the firing point, the spark and the burn is going to push down on the rod, piston and rod. And this is just where my mind goes. If the pin is, pushing the rod up, and then the explosion, the spark pushes the rod back down, they're pretty much already, touching and so on. So I'm bringing this guy up, the spark happens, and there's not like much travel, like we're already in contact. And so what I'm trying to explain is, if on the exhaust stroke where crank is bringing up the rod and then it goes to switch directions, there's nothing that on top of the piston that's going to push it back down towards to touch, to get close to the pin. And so I'm thinking if at TDC it changed direction, then it goes boom to this area on the exhaust stroke and it makes a loud knock or a louder knock. And I'm curious or wondering if that's why it's such a bigger amplitude on that column, which would be exhaust for number 7. If it's because of the change of direction, then it'll, especially if there's no bearing and no oil pressure, is when you're hearing it, because it'll travel up, hit the crank pin, and make a noise, and then the crank brings it back down. That's the only thing I can come up with. Now, obviously, you're getting some noise there also on its compression and firing point. Naturally, if the shell is completely gone, you're probably going to pick something up. But it wasn't that as apparent in that area throughout the whole capture. Sometimes it's there, sometimes it's not. And again, I'm wondering if it's because you're already like close to that point, and then you're pushing down on the point you're already on. You're not changing direction with nothing pushing on top of it to keep it from flying and then knocking here when it changes directions. That's the only thing I can think of. Again, that's just where my mind goes. I try to justify things or think about things or ask myself why when I see things. But that's probably just a little bit way too much in depth about it. This one's been one that I've been wanting to do for a while. I'm glad I finally got another known bad car to be able to try it on. And it's a lot of gibberish, but it's a lot of cool things on the screen as well. So just food for thought. I think that the question's answered, that you can see a rod knock. You see a rod knock through the oil pressure reading and syncing it and helping with the microphones, and just put all of those informations together and knowing your firing order and some engine theory and operation, you can pick one out. Again, like I said, imagine this was number 4. Imagine they didn't run it to the point where they got it too hot and distorted the rod. And it's the only one of 2 rods you can get access to on the, now this guy's going to get an engine. Imagine what the price of this engine is versus 2 bearing shells, 2 rod bolts, and getting an engine back up and running. If it was to the point where it was salvageable, and you can use your scope, sync it, find it, identify it, look at instructions, seeing if it's accessible, and finding out that it is, and that you can save an engine, that's powerful right there. That's it's cool and powerful, and that was the main reason why I wanted to do it in the first place with the other cars. But I'm glad I got to see this and do this and run into this, and also cool also to know about with the scanner, and also sat there thinking about it. I mentioned like not sure how it does it, but if you think about that also, knock sensor, it's mainly looking for bad fuel or pinging per cylinder when ignition happens. It knows cylinder 4 ignition is happening here at this point. And what are the knock sensors picking up? A ton of noise. It thinks that number 4 is having a fueling knock problem because the rod knock from the change of direction on number 7 is occurring at that same point. It's not a fueling mixture ignition timing problem, but it's picking up a rod knock. But the algorithm in the DME you could tell it's working. It's picking up a noise for number 4 column. So that's how I can justify that or explain that in my head about why on the scanner in live data it's saying number 4 has higher voltage and is the one that is having a knock issue. So that explains that as well. And that is everything with this. A little bit long-winded, but definitely for me a cool one. I hope you liked it. Till next time.